Also, we can really peer such a long way out that we can see practically back to 13.8 billion years ago, quite a while back, which is extremely near the Big Bang. We currently know how our reality ends. Our proclivity with science fiction films and maybe the Bible would highlight the enormous, dramatic end of the world. Yet imagine a scenario where we tell you that the end of the universe is the same as its initiation. The James Webb Telescope has uncovered that the universe has stopped growing. Well-known researcher Brian Cox made this prediction a long time ago. In doing so, he gave us the most reasonable starting point to envision the apocalypse. We can hope to light that started its journey before there were worlds, and that is the oldest light in the universe, which, by the way, is one of the pieces of evidence for people who try not to believe in the Big Bang. The answer is, well, you can see it. We're going towards Big Bang 2.0. Join us as we explore why the universe has stopped extending and James Webb's frightening discovery. On the off chance that we're sure about anything in our insight into the universe and its history, it's the reality that our extremely amazing presence is unified around this event called the Big Bang. Obviously, there are elective speculations that recognize the start of the universe, like eternal inflation or a wavering universe. However, we're not getting into the legitimacy of these speculations today, primarily because the galactic community has now promptly acknowledged that our history in this universe starts with an enormous explosion. While the Big Bang is a common term in the theoretical field of cosmology and space, we're not really aware of the details and the enormity of the phenomenon, unless you're a geek who has spent hours watching some amazing representations of the Big Bang. To be fair, the phenomenon was more than just a blast, or so to speak. Just put, the Big Bang sees its beginning in a singular point. A point that was boundlessly hot and thick that expanded to extreme lengths. All of this was when the universe was incredibly young. In all honesty, at the time of the Big Bang, the universe was simply 10 to the power of minus 34 seconds old. That is, 1/100th of a billionth of a trillionth of a second in age. This is when the universe experienced an incredible burst of expansion, otherwise known as the infamous inflation. During this cycle, space expanded faster than the speed of light. No doubt you could not have possibly even blinked when the universe grew multiple times in size, nearly instantly, from subatomic size to golf ball size. 1 second after the expansion, the universe began to cool, and that led to the formation of matter as we know it today. Indeed, to the extent that the timeline goes, within less than a second, our universe was filled with every particle we've learned about in our science class: protons, neutrons, electrons, positrons, photons, and neutrinos, forming the aftermath of the Big Bang. Exciting, right? Well, allegorically, it seems that way. Yet, how we understand the universe's commencement is deeply theoretical. We've come a long way since the first moon landing, and since then, our technological progress has developed dramatically. Back when researchers were studying the Big Bang just based on mathematical equations and theoretical models, they wouldn't have imagined that we'd investigate the possibility of life on Mars. There have been a few major breakthroughs in our efforts to study the universe and explore space. Yet, even now, our current technology is limited. We can't reproduce the Big Bang or look back at the actual event. Our greatest piece of evidence comes from the cosmic microwave background, which has allowed scientists to observe the echo of the Big Bang. While this method is well known in the study of the universe, it's also theoretically limited. The greatest limitation in this specific approach is that we can't see the gravitational waves or the residual radiation that came from inflation itself. So, while our entire understanding is based on theoretical principles, scientific theories have a significant room for being discredited, too. That's right, we're almost certain about the Big Bang as a concept and how it was fundamental in creating our universe, but there are some pieces of the outcome we've misunderstood. Also, as surprising as it might be, theories about our universe are largely based on information that is prone to human error all the time. Simultaneously, some of our information is also highly decisive about the Big Bang. As of now, let's just say that over time, it's hard to refute the theory outright. In the past few years or so, our only saving grace to study the Big Bang was the Hubble Space Telescope. And now, of course, all bets are on the phenomenal accuracy of the James Webb Space Telescope. Before we got to use these powerful technological instruments, one of the biggest debated matters in cosmology was the expansion of the universe. If you picked some science textbooks from the mid-90s or so, you'd learn about how the universe is expanding. At the end of the day, the universe is growing, and that is one small scientific truth that we've clung to. Nevertheless, the real mess here is that maybe we don't actually know what the expansion of the universe involves, and that's just the tip of the iceberg. Critically, we must ask ourselves if the universe is really expanding, since, heads up, the James Webb Space Telescope is telling us otherwise. Lo and behold, the universe has stopped growing. And hey, while the world is still perfect, you should upgrade your web experience. No problem at all, since we certainly have. This is why we're happy to unveil our own secret to getting deep content and making some powerful educational videos. The present video is supported by the champion of safe and accessible web, Atlas VPN. With more than 6 million clients worldwide, Atlas is changing the game for everyone. Okay, this help won't be available in space, but Atlas would make your web experience very secure and fast. Can't watch shows that are blocked in your region? Connect with Atlas VPN and presto, you're in. You don't need to be a tech expert to use this service. It works for everyone. That's 2 for just $11.83 each month, plus 90 days extra. So why pick Atlas? Atlas kills malware attacks, keeps your searches secure, unlocks content from around the world, and offers the best deals on the market. You can get all of this for all of your devices via a single subscription. Grab the special deal, as now Atlas VPN Premium is just $1.83 per month, plus 3 months extra, with a 30-day money-back guarantee. Protect your privacy and enjoy the benefits of Atlas VPN at an incredibly low price. You can take this deal by tapping the link in the video description below. Be quick, as it's a limited-time offer. So, while we thank Atlas VPN for supporting this video, click the link in the description to benefit from the limited-time offer. Your web experience just got a lot better. And now, before diving into the implications of this major shift in our universe's trajectory, let's just discuss our understanding of this confounding phenomenon. In the lead, the most well-known information related to the Big Bang describes it as an explosion, and well, fiction and popular media have placed strong imagery on this process too. Any piece of media would describe the initiation of the universe as some sort of a blast that expelled lots of energy and matter in every direction. Logically speaking, that kind of representation isn't accurate. Despite the widespread use of the word explosion and inflation, the birth of the universe wasn't exactly an impact. Scientists believe that we should correct how we understand the universe. In NASA's own words, the universe didn't just pop into space as space. Before the universe, rather, it is better to consider the Big Bang as the concurrent appearance of space everywhere in the universe. Our understanding of the phenomenon also reveals that our universe has lived through a solid vast period that was only interrupted by reionization in space. Before that specific chemical event, our universe was simply pitch dark. Let there be light. The moment of the universe's light only happened for 100 million years after the Big Bang. That's right. The Big Bang only established the fundamental elements of all living creatures and heavy bodies in the universe. For 400 million years, the universe was plunged into darkness, since, well, it's simple, there were no stars or galaxies. When that was corrected, as clouds of gas turned into stars and galaxies, it was only then that the universe emerged from its primordial dark ages. So here's a little random fact for you folks. When do you think our solar system appeared, assuming the universe was just darkness and terror for 400 million years? Well, our solar system was born 9 billion years after the Big Bang. No kidding. Sorry, science fiction movies, there's a huge gap between the so-called explosion and scientific theory. And obviously, this changes everything. The state of affairs. Our universe still exists as a singular commencement point. It hasn't moved or expanded since the Big Bang. What really happens is that space has been expanding from the beginning, and it carries matter with its expansion. To put it simply, the universe isn't growing the way we imagine it or even understand it. It's actually the dynamic expanding of space that precedes the development of the universe we know. It's a bit complicated to grasp, but it's also crucial to understand the implications of what we're about to tell you. For the purpose of this video, we continue to use the term expansion of the universe to denote the dynamic development of our space, mainly because even scientists are happy to use this specific framing to describe the new discovery made by the James Webb Space Telescope. The fact that the universe has stopped expanding is both frightening and conflicting with our previous theoretical understanding of this puzzling phenomenon. So what do we make of it? Let's dig into that. To understand the extent of the implications, we need to go back to our current studies of the universe. Back when the universe was created, aka during the Big Bang, our universe was smaller than a single molecule. Since then, the universe has been expanding outward continuously. At first, it expanded outward at unimaginable rates, but as the universe grew older, it continued to grow and stretch more. This is the moment everyone thought would last forever. After all, if the Big Bang was a beginning of sorts, we should expect a corresponding end. Our theoretical knowledge, therefore, suggests that our universe is on a specific path of expansion with no conceivable chance of stopping. In short, we were certain of the universe's constantly expanding nature, and that idea would have allowed us to figure out how and when the world would end. The James Webb Space Telescope breaks our assumptions about the universe's expansion. JWST's new study reveals that the universe has stopped expanding. The new images that the James Webb Telescope has captured suggest that the universe's expansion has significantly slowed down. In fact, the universe may not be growing at all. How precisely did this discovery come about? Well, with the new images, scientists have revealed that light waves have been apparently bending as they have traveled through space and time. The very bending nature of the light indicates that space has stopped expanding. The new pictures reveal something far beyond what the Hubble Space Telescope has achieved. Our previous knowledge depended on Hubble studies, and thus it didn't uncover the most significant aspects of the universe. The new images have shown that the universe is essentially curved. This astonishing revelation, therefore, shows that the universe is a circle, and our very existence, including reality, is wrapped inside this circle. With this, another significant advancement is the light that has reached the new telescope. The more we look at the images, the more evidence we have that the theory of the Big Bang is both valid and outdated. It is valid because the universe started at one point and has been truly expanding. However, it is outdated because the universe's expansion has been largely disproven with JWST's new information. If we focus on the data, we see that the universe, also known as the circular point, has stopped growing. And that very nature of the universe refers to the most likely fate of the universe's end. As we said, the universe was created with a Big Bang, but we have never stopped to consider what might be the specific nature of the universe when it ends. Scientists have uncovered the potential outcomes of how the world will end. And fair warning, the end will come in the same way it started. The expansion has halted, and what happens next is simply that the expansion of space would also slow down. The new data also reveals the possible end, which is the Big Crunch. We know it's a lot for anyone to wrap their heads around, but JWST is allowing scientists to observe the mechanisms of the universe. Thus, we are now aware of the universe's trajectory. Instead of accelerating expansion, the universe has stopped expanding, and consequently, with time, this curve or the circle that holds our universe would progressively collapse. This theory is not new to scientists, but it's only with the James Webb Space Telescope that we have the proof to confirm it. Imagine it as a round trip. Our universe has reached its peak of expansion, and soon enough it would begin collapsing on itself. This collapse is the death of the universe as we know it. The James Webb Space Telescope is an astonishing creation that is paving the way for how we understand the universe. The latest images from the telescope reveal that light is bending at the edges, which means our universe has stopped growing. Moreover, it also means that we're closer to our ultimate end than we naturally thought. Whether this will happen in the next few hundred years or a few thousand years is anyone's guess. But for now, our understanding of the universe has reached an incredible stage, which, by the way, is truly frightening.